Hello, students. Today we're working on modeling with two variables, and we're going to focus on data that will be modeled by a line. And so we're going to do a process called linear regression on this. And you'll see that I've given you an example of what one would look like, where data is plotted, and those are the squares or the dots that you see. And then using your calculator, we can do some math to create a line that will be a best fit of this data. And then you can use that line to make predictions or see trends in what is happening with that information. So we'll use your Desmos graphing calculator to find these lines of best fit. So I have an example data set right here on the year and then the number of doctors in a certain town during that year. So one piece of vocabulary to be familiar with is the difference between an independent variable and a dependent variable. So an independent variable is going to be like the X part of your data. And generally, it has to do with time or something that you wouldn't really want to make the prediction about. So this, in this problem, is the year. That would be the independent variable. And then the dependent variable is the one that you're trying to make predictions about. So, for example, how many doctors would be in this town in a year? So it depends on whatever that independent variable was. And so generally that is the Y value. And often in a table situation, the independent variable is listed first and the dependent variable second. Or they, if they're left and right columns, you'll have the independent one on the left and the dependent one on the right. So some of this lesson is just going to be learning how to type this into Desmos. So if you'll get to your graphing calculator on Desmos, it says to, on the left side of the screen, hit the plus sign. So we are looking for this symbol. And I'll go ahead and get on Desmos myself and let you see those. Let me get rid of these graphs. So this is the plus sign. When you hit that, it comes up with these. And the first thing you would need to do is to enter the data into your table. So I'll go ahead and do that. And I may have to flip back and forth between the two screens. So I think the first year was 1960. I find it easiest to go through and do all of the years first. So let me scroll back up here. 67, 70, 75. Get those. And I'm just hitting the down arrow, going from one year to the next. Then we have 82, 85, and 86. Okay. And then we'll go on and do your next part. And it looks like it took me out of okay, there I am. So then I've got this data I'll have to get typed in. So so 29, 37, and sorry, this is not really all that great. 3511, 3754. $41.73, $47.41, and I think I've got one more piece of data to type in. 5019 and 5102. Looks like maybe I skipped an X. All right, so that one goes with 1986. This one goes with 1985. And I'll look to see what X I might have skipped. 1982, possibly. Yes. All right, so now I have my data entered. So then if we go back to what it says to do next, it says after you've typed it, you can't really see your data. So we want you to select this magnifying glass. So that would be, I'm trying to get my pen to work. Okay. Sometimes my pen doesn't want to react. Let's see. Right there. Okay. So this magnifying glass, get rid of those marks. And so if we go back to Desmos, I would hit this and it will do a fit of my data. So that would be your next step, is to get to where you could see your data. Then as we move on through your instructions, it says to select the plus sign again. So you'll be selecting this plus sign right here. And you will want to select the expression. Okay, so we'll go back to Desmos and plus sign. You're going to select expression. And this time you're going to type in, I'm going to go ahead and type it, y1. And then instead of an equals, you're going to use the, I call it a tilde sign. It's a little wavy symbol. It is right underneath the escape key, and you'll have to shift to get that. And then we're going to make this look like mx plus b, but we'll have to go mx1. And notice I'm just typing the number 1, but Desmos is putting it as a subscript, and then plus b. And so what you'll see is that the computer has, or Desmos, the calculator, has done what we call a linear regression. They have found a line that fits this data. And so you can see that it's calculated your M and your B values. And I'll explain this R in a little bit. So I'm going to go back to where we are on your notes. So we've typed in that information. And there's one other piece that I'm going to have you look at. These are called the residuals. And that's going to just be a little graphical way of telling how close your data points are to the actual value. So if I hit plot right here, it gives me these residual values. I can also see them on my graph. These are the blue dots. And if you get a dot that is far away from the x-axis, that lets you know that that data point is not as well predicted by the line as some of the others. But these residual points tell you how far this data point is from the line that's been graphed. So we've got one that's 8 units away. This one's negative 0.15, so very close, negative 6.7. This one's the furthest away at negative 18, so it's 18 below. And then these two are both 10 units away from the line. And as you zoom out on the line a little bit more, you might see those points a little bit further off the line. So I'll go back to where your notes are. So those are the different pieces that you have to go through. And then we have some questions about the model that we want you to answer. So the first thing would be for you to answer the what is the model equation. All right, so I'm going to have you, I'm going to get to where I get this classic view of the mouse. All right, I'm going to have you go back and look at this part right here. This number is M, and it's covered up by that keyboard, but this is M, and this is B. So in your equation, you'll have Y equals, and then M, which is 83.1952, and then we'll put X, and normally we would put plus, but your B is a negative, so I'm going to go ahead and leave the minus sign, 160,134, and that may seem like it's kind of an odd number, but remember that this is real data, and so it isn't always just nice small numbers that we usually find. All right, the next thing that it asks you to find is your correlation coefficient, and this is R that is in your list of information. So right here is R, so it equals 0.9999. And if you think about that as a percent, that is 99.99% accurate. And so the closer that this is to 1 or negative 1, if the line had been a negative slope, this would have been negative, then the stronger the correlation. So this is a strong correlation. That means that it's a very good fit for the line. The line does a really good job of predicting what the data is doing and what it will continue to do if it stays on that path. So then this question is going back to the residuals and wanting you to look at what's happening according to the residuals. What data point is furthest from the line of fit? So I tried to talk about that as we were first looking at it. This one is 18 units negative off of what the line is saying. And so this is the ordered pair, 1982 and 4,741. That would be the ordered pair that is the furthest from the line of fit. So we want to write that as an ordered pair. And then how many points underestimate? So those would be the negative residuals, 1, 2, 3, 4. We have 4 that are in the negatives. And then how many overestimate? So 1, 2, 3. 3 of them are overestimates on that line. And then here's where you're going to do your algebra. So it says predict the number of doctors in 2021. So if this trend continues, and by the way, this data is a little outdated, so you have to take your results with that in mind. But if we use our best fit line, so I'm going to bring it so we can see that, you would have Y, which is your number of doctors, equals, we would use our best fit line, so 83.1952. And then we're going to put in 2021 for the X, and then minus 160,134. All right, if we do that calculation, and we can use Desmos for it, we'll find out what the line would predict as the number of doctors in that year. So again, we take the M, 83.1952, multiply it by 2021, that's our X, minus, and then our B, 160,134. And then this is something we would round to the nearest whole number, since it's asking about how many doctors there would be. So 8,003 doctors. If this trend would continue in this direction, in this way, there would be 8,003 doctors in 2021 in this town. And this question asks, when would the number of doctors reach 6,500? Well, remember that the number of doctors, that would be the Y value. So this is the dependent variable. So for this one, we know the Y value is 6,500, and we're trying to find the X value of when that would occur. So the X is going to be our variable, and so we'll have to do some algebra to solve for X. For example, you would first of all add 160,134 to both sides of the equal sign. And so this is going to give us 166,634 equals 83.1952x. Maybe I'll put that in blue so you know where I'm getting that number. And remember, we're solving it for X. So the next thing we're going to need to do is to divide both sides. So we divide both sides, taking 166,634 and dividing it by 83.1952. Do that to both sides of the equation. Then there would be that side canceling, and you'd have, and again, you could do this on Desmos. So going there, taking 166, and it was 634. And we're dividing that by 83.1952, and you get 2002.9, which we could round up to 2003. So 2003 would be the year that your number of doctors would reach 6,500. So in the year 2003. So that's an example of the work that you'll be doing, and how you can get on Desmos to do that. And so be sure you ask questions as you continue to work on your homework.